In this last objective of Section 8, we are going to interpret a function graphically, which means that we will use a graph of a function to find function values, intercepts, and the domain and range of the function. So in this example 8, we have a graph, and let me just describe it for you, that's in two different pieces. We have part of a parabola that opens down, and then we have part of a line segment. So the parabola goes through, it starts in the third quadrant and goes through this point -2, 0, and then it goes through -1, 3, and up to the point 0, 4, and then it curves back down to 1, 3. And that is the ending point of that particular piece. Then the line segment picks up with an open circle at 1, -3, and then it goes through 2, -1, 3, 1, 4, 3, and then it ends at 5, actually a little bit more than 5. This is more like 5.5, 6. So if we want to find f of -2, recall that f of -2 means to find what is the y value when x is -2. So the y value when x is -2. That is, on the graph, we're looking for an ordered pair of the form -2 some number. And so we go to the x value of -2. In fact, the graph intersects the x-axis there. So the point on the graph is this point -2, 0. The y value when x is -2 is 0. So f of -2 is just 0. F of 1 means what is the y value when x is 1. If we go to 1 on the x-axis, notice that it looks like there's 2 points, but remember, with the definition of a function, for every input there can be only one output. And if we go up, we see the closed point 1, 3. Going down, we see an open point 1, -3. Well, the open circle means that point is not included in the graph. The closed circle is included. F of 1, therefore, is just simply 3. F of 2 means what is the y value when x is 2. So we go to 2 on the x-axis, and where does it meet the graph? The graph actually includes this point 2, -1. So f of 2 is -1. Now part D asks us to find all x for which f of x equals 3. Recall that f of x is y. So this time we're trying to find out what x values have a y value of 3. And so we go to the y-axis at 3 and look left and right to see if any points intersect with that line, and we do see it. There's a point at -1, 3, 1, 3, and 4, 3. So there are actually 3 solutions of this equation. The x values are -1, 1, and 4. And part E says find all x for which f of x equals -5. So now we go to -5 on the y-axis, which is going down, and look left and right to see if we see a point on the graph that corresponds to that y value. And there is a point at -3, -5. So the x value that has a y value of -5 is -3. The x-intercepts, remember those are the ordered pairs where the graph crosses the x-axis. It crosses the x-axis in 2 points, specifically at -2, 0, and looks like 2.50. The y-intercept is where the graph crosses the y-axis, which occurs at one point, which is at 0, 4. The domain of the function, remember we read the graph from left to right, thinking about where do we start. So we have a graph to the left. It kind of starts at, looks like at -3, but remember that arrow means that it continues to the left. And then this parabolic shape continues until we get to the point x equals 1. So if we extend down from the 1, and it's including the 1 there. Now the second piece now picks up, but that 1 is open, but an open circle on top of a closed circle is still closed. And then this piece continues until we get to about 5.5. And notice that that's a closed circle, so it specifically ends at 5.5. And that is a bracket because it has a closed circle. So everything to the left of 5.5 is included in our domain. We write that as -infinity to 5.5 with a bracket. The range of f, we're going to think about drawing a copy of the y-axis to the right. Read from bottom up. The bottommost point has an arrow extending down, so we know it continues infinitely down. And if we think about this parabolic piece, it goes up all the way to the y value of 4. And then it comes back down, but those points are already included. And then the second piece goes over at -3, but it's open on top of a closed, which still means that it's already included in our graph. And that piece goes all the way up and doesn't stop until we get to, looks like 6. So we don't need to stop it in two pieces because we're looking at what are all of the y values that are included in the graph. So 4 is included, but everything above that to 6. So we don't actually have to write two separate intervals. We write from -infinity to 6 with a bracket. And then example 9, we have a graph that has a line segment and just some points on this so you can get an idea. It's like -2, 6, and then that goes through -1, 5, 0, 4, and then there's an open circle at 1, 3. So that's the line segment that we have. And then we have another part of a parabola that has a point at 1, 1, point at 2, 0, 3, 1, 4, 4, and then it extends upward to the right. So to find f of 2, again, means to find what is the y value when x is 2, right? 2 and some number, what would that be? Well, f of 2, if we go to 2 on the x-axis, it actually intersects the graph at that point, so the y value at that point is 0. F of 3, what is the y value at x equals 3? We go to 3 on the x-axis, and if we go up to our graph, we see that the y value is 1, since the point 3, 1 is on the graph. F of 0 means what is the y value when x is 0? So if we go up from the origin, we see the point on the graph is at 0, 4. So the y value at that point is 4. And then f of -2, what is the y value when x is -2? If we go left to -2 and go up, we see that our point is at -2, 6, so the y value is just simply 6. Now, I didn't ask you to find this here, but what if we wanted to find f of 1? F of 1, remember, it looks like there's 2 points, but one of those is not included in the graph. The only one that's included is the 1, 1, so f of 1 would be just simply 1. And then part E is find all x for which f of x equals 4. So this time we go to the y value of 4 and go left and right to see where we meet points. And there's 2 points, right at 0, 4 and also at 4, 4. So the x values, whose y value is 4, are x equals 0 and 4. So to determine the domain, we're going to have a copy of the x-axis below the graph. Go from left to right. Where do we first see a point in the left direction? And that is at this point, -2, 6. And notice that it is a closed circle, which means at that point it's a specific end to the graph. And then that line segment continues until we get to the x value of 1. But there, that x value of 1 is open for that particular line segment, so I'm going to put an open circle at 1. But then our half parabola, part of the parabola, starts at the x value of 1 also, but it's closed. So whenever I project it down, it's going to be a closed circle at 1. And notice that that piece continues to the right infinitely because of the arrow on that right endpoint. And so everything to the right of -2 is included in our graph. We don't have to stop at 1 because 1's included in everything to the right of it. So our domain is just from -2 to infinity. And then the range, if we draw a copy of the y-axis to the right, and think about what is the bottommost point on our graph. So as I go up, my bottommost point is at this. Be careful here, the y value of that point is 0. So we project over to the 0. And then the graph goes up. It goes up infinitely for that part of the parabola. Now the other piece of the line segment, just understand that those y values are included in the parabola. It has a point at 6 and this 3, which is open, but we already have it included from the parabola part. So we don't have to stop there, right? It's already included as a point. So we say that the range is from 0 to infinity.